Hello students, this is Rolle's theorem. The theorem states that between any two consecutive real number roots of a equation fx is equal to 0, there lies at least one real root or an odd number of real roots of first derivative of fx is equal to 0. So between any two consecutive roots of fx is equal to 0, there exists at least one or an odd number of real roots of first derivative of x is equal to 0. So how we can prove this? Let alpha beta be two consecutive roots of the equation fx is equal to 0. So we have taken alpha and beta are two consecutive roots, so that fx is equal to x minus alpha into x minus beta is equal to phi x. So phi x is the quotient here, and alpha and beta are the roots of the roots of fx. So this can be written here in this way. So now here phi x we have taken not equal to 0, phi alpha not equal to 0 and phi beta not equal to 0. Since alpha and beta satisfying fx, so we are taking phi x is not satisfied by alpha and beta, so we will get different roots of phi x from alpha and beta. So since phi x has no roots between alpha and beta, so phi x maintains the same sign between alpha and beta for all x. Alpha and beta have phi x has no roots between alpha and beta, so phi x must have different root from alpha and beta and no roots between alpha and beta. So phi x maintains the same sign between alpha and beta for all x. Therefore phi alpha and phi beta are of same sign. Since if fx is satisfied by alpha and beta, then phi x is not satisfied by alpha and beta, and since phi alpha not equal to 0, phi beta not equal to 0, so here phi x maintains same sign between alpha and beta. So we can differentiate this form. After differentiation, the first derivative of x becomes x minus alpha phi, first derivative of phi x, phi x minus alpha phi x plus x minus beta phi x, and plus x minus alpha x minus beta and first derivative of phi x. So this is the first derivative of fx. Now putting successively x is equal to alpha and beta, we get here, if we put here in the first derivative of fx alpha and beta in place of x, we will get first derivative of f alpha will be alpha minus beta phi alpha. This will be cancelled, this will be cancelled, we will get the alpha minus beta phi alpha. And if we put beta in place of x, then first derivative of f beta will be here, this and these terms are vanishes, it will be beta minus alpha phi x phi beta. So this 2 will get if we replace x by alpha and beta into first derivative of x. So here we know that phi alpha and phi beta are of same sign, since we have already proved that phi x and phi alpha and phi beta will have the same sign. So here we can very easily see that alpha minus beta and beta minus alpha must be in opposite sign. So these are of same sign and these are of opposite sign, means first derivative of alpha and beta, first derivative of beta must be of opposite sign. So these are of opposite sign. Now if these are of opposite sign, then first derivative of ax is equal to 0. Means if we know that if any curve, and these are, we are taking first derivative of ax is equal to 0. Here we are getting f phi alpha, first derivative of f alpha, and here we are getting first derivative of f beta. Since these are all opposite signs, so this must be in this form. So here we must get a point where first derivative of x must be equal to 0. Since for two consecutive roots of alpha and beta, we are getting opposite signs. So here first derivative of x is equal to 0 must have at least one root. This point is one root, or there may be at least an odd number of roots between alpha and beta, or this can be in this form. This can be 1, 2, 3, 4, 5, 6, or we have to take in more one. I have taken in this way. Seven. So here this is phi dash alpha, and here this is phi dash beta. First derivative of alpha and first derivative of beta. So you are getting odd number of roots 1, 2, 3, 4, 5, 6, 7. So you will get at least one root, or at least odd number of roots between alpha and beta. So if you like this video, then like, share with your friends, and if you have any question, then ask me through comment.